So Adam described what we're going to be talking about today pretty well. I'll be talking about Neo4j and Python together in the context of data analytics, and I will go into later how that context differs from other contexts in which you might use Neo4j and Python together for other reasons, and why this context deserves its own treatment. So with that, today's agenda. We will talk about first, what is a graph? I'm not assuming everyone here knows what Neo4j is, so we'll have a short little introduction to graphs and graph databases. So what is a graph? And then we'll do a from SQL to Neo4j exercise to get people who are from the relational database world up to speed on how you would store your data in Neo4j in a graph database. And then I'll do a short little demo of Py2Neo, which is my favorite Python driver for Neo4j. I'll first show its syntax, how the API is used, and then I'll scroll through a small script I have that talks to the Twitter REST API to get Twitter data, and then adding it to Neo4j with Py2Neo. And then I will go into an IPython notebook and show how you can very easily integrate your Neo4j database into an IPython notebook. As most of you know, if you are already doing data analytics types of things with Python, you probably use IPython notebooks. So I wanted to show how easy it is to integrate Neo4j into that. So what is a graph? Pop quiz, the first and only pop quiz of this webinar. Are these graphs? Take a few seconds to ponder. The answer is no, they are not graphs. These are charts. When we talk about graphs at Neo4j, and anytime I say the word graph, this is what I'm talking about. It is a collection of nodes that are connected by relationships. So that is a graph, especially in the academic world and in the analytics world. When someone says graph, it's very possible they're talking about a mathematical graph that consists of nodes and edges. And in Neo4j, we don't say edges, we actually say relationship, but it's the same thing. All right, so from SQL to Neo4j. So like I said, a lot of you are probably familiar with SQL databases, both storing data in SQL and querying it with SQL. So real quickly, we're going to go on a short journey from SQL to graph. So we're going to take a data set and look at how you would store that most typically in a relational database. And then I'll take that same data set and show how you would store it in Neo4j. And also along the way, I'll highlight some reasons or advantages of storing your data in a graph as opposed to a bunch of tables. So we're going to take YouTube as an example, or any YouTube-like service where you have users and channels and users, viewing different channels. So in the relational world, in the relational database world, you would probably start with a users table and a channels table, where the users table is just going to have all your users, probably their username and password and any other important information about the user. You would have a channels table with the name of the channel, perhaps, maybe other fields to indicate other details about those channels. But in this little example, we're just going to have the names here. And then if we wanted to capture information about users operating channels, or users owning channels, let's say, you would create another table, probably called users channels, to capture which users own which channels. So here on the left, we would have a user ID column that would have a foreign key back to the users table. And then we would have a channel ID column that would have a foreign key over to the channels table. And this would capture things like user 2, which is Bob, owns channel 1, which is Bob's gaming channel. So anytime you want to capture a relationship between two entities like this, you would usually have to create a table like this. And then if you wanted to capture any information about, if you wanted to also add any details about this relationship, you would just have some more fields in this users channels table. Like if you had perhaps the date that the channel was created, you would have another field in this users channels table saying date created, and then with a date time, property or value rather. So right, when in SQL world, when you want to capture relationships between two entities, and by entity, I'm going to use the word entity for these table type things. I'm going to say like a user is an entity and a channel is an entity. To capture relationships between them, you usually create a table like this. And then let's say you also want to capture information about users subscribing to other users' channels. So you would create another table, maybe call it user subscriptions. And this is the same story where you have one column, one field that would be the user ID field that would have a foreign key back to the user's channel, the user's table rather, and then you would have a channel field, channel ID field that would have a foreign key back to the channels table. It's the same thing here, and this would capture which users subscribe to which channels. And when you have your data modeled like this, it's hard to answer questions such as, how is Charles related to David? It's really easy to ask questions like, how many channels does Bob have? But when you want to do something where you don't know how many steps are between two entities, such as Charles and David, it's very hard to write the SQL query to figure it out. And not unrelatedly, it's hard to look at this data model as we have it right here and figure out how Charles is related to David, because it could be that Charles subscribes directly to a channel that is operated by David, but it could be that Charles subscribes to a channel that is operated by someone else who subscribes to a channel that is operated by David. So things like that where you don't know, where you have a variable length question, you don't know if it's one step or if it's 4 steps away. Neo4j is very good at that because you, in SQL, you have to explicitly define how many times you want to join a table on itself. Also in connect by, you have to be very explicit. And Neo4j allows you to ask these types of questions in 3 lines or less of the Cypher query language, which we will look at later. So that is a disadvantage of storing your data in SQL is it's hard to ask questions like that. So let's look at how we would store YouTube in a graph, in a Neo4j graph database. So in Neo4j, there are different node labels. So here we have user nodes in blue, and we'll have channel nodes in green. So this example Neo4j database is only going to have 2 node types. We call them node labels. So we'll have users and channels. And then all of these nodes are going to have properties on them. I'll just call it a name property. You could also call it username or whatever you think is appropriate for a YouTube data set. And then we would put string properties on all these nodes indicating their names. Same for the channels. We could also give them a name property. And this is the same data that I showed on the previous slide. And then we also wanted to capture users operating channels. So to do that in Neo4j, you would create a relationship and you would call it type operates. You can call it whatever you want, of course. I'm just calling it operates. So Neo4j supports both different several node labels and several relationship types. So here we would have a relationship type of operates, outgoing from a user node to a channel node, indicating that this user operates this channel. So here we see David operates 2 channels. Alice does not operate any channels, and so she simply just does not have any outgoing operates relationships. There's no sense of null values in Neo4j. It's not as if Alice has operates relationships pointing to some null node or something like that. The relationship just does not exist if the event has not occurred, or if the data is not there. And then we also wanted to capture users subscribing to other users' channels. So with that, we would create a different relationship called subscribed, perhaps. Again, outgoing from a user node to a channel node. So here we see that Alice subscribes to 2 channels. She subscribes to a channel that's operated by David and subscribes to a channel that's operated by Charles. So with your data stored like this, it's much easier to answer the question that I posed earlier, how is Charles related to David? And it's related to also how we sit here and model our data. The way we've drawn out our graph model is very similar to how you actually store your data in Neo4j, because everything in Neo4j is either a node or relationship, and those nodes and relationships can have properties on them, as we see here. So we see visually, it's very easy to see that Charles is related to David in a couple of ways. So we see that Charles operates a channel that's subscribed to by Alice, and Alice subscribes to a channel that's operated by David. And not unrelatedly, it is very easy to answer this question with Neo4j's cipher query language, because the graph is very good at finding how two entities are related, regardless of how many steps might be between them. So that is a short and quick summary of Neo4j, what a graph database is, and the advantage. One of the advantages, really, there's several advantages. One of the advantages of storing your data in a graph. So let's jump into. Let me make this slightly bigger. Nope. Into Py2Neo here to look at its syntax and API, because if you're using Neo4j for data analytics, you're probably going to want to start with collecting data. So I use Py2Neo for all my data collection purposes. And I should probably also mention that Neo4j is traditionally used to power applications. So we have a lot of our customers, they'll use Neo4j to serve up recommendations on websites or serve up recommendations on a dating app or something like that. But Neo4j doesn't have to, not all databases and not all Neo4j databases need to power an application. I use Neo4j personally and professionally just for storing highly connected data for the purposes of analytics. And the first step of that is data collection. So an example of some of these projects that I did in grad school, I did a project on Twitter data where I collected tweets by politicians and then did a few some analytics around that, and I just simply used Neo4j to collect and store this data so that I had it in a safe place, and I wanted to, of course, store it in a graph database because it's fully ACID, fully transactional, and I feel safe when my data that I'm using for a very important project is stored in a database rather than perhaps a data analytics, graph analytics engine, which is not a very safe place to store your data. So I think having a database behind your analytics projects is very important. And if you are doing a highly connected, if you have a highly connected domain for your project, it's very likely that Neo4j is going to make your life a lot easier if you store your data in a database rather than an analytics engine. But with that said, let's start looking at Py2Neo. Like I said, it is my favorite Python driver for Neo4j. So you would just install with pip install Py2Neo. So I'm just going to get started here. So you import the graph object. I'm just going to show a few of the low-level API calls here. So I need to also import node and relationship. So mostly you'll import graph, node, and relationship, and this will give you everything you need to start adding data. So the syntax is pretty easy in Py2Neo. If I want to create a node, I'll use the node function here, where the first argument is going to be the node label. So remember in our previous example we had users and channels. Those were node labels. Here I'm going to give this node a label person, and then I'm going to say the name is Nicole. And all of the arguments after the node label is just an arbitrary amount of key value pairs, and those are going to be properties on the node. So that will not create the node in the database quite yet. You have to pass it to graph create, and that should create a node over here in my hopefully empty database. Here we go. There I am. So the syntax in Py2Neo is super easy. So I might create another node, another person node perhaps, call it Atom, with name Atom. And then, of course, again, that's not actually creating the node in the database. You have to pass it to graph create to actually send the REST API call to create it. And then, of course, a database is no good without relationships. So you can also use the relationship function here in Python Neo, which has a very easy syntax. The first argument is the from node. So I'll say Nicole knows Adam. So the second argument there is the relationship type. I'm going to say it's going to be relationship type knows. And then the to node is going to be the Adam node that I defined earlier. And that will create a relationship between those two nodes. So that is really, I mean, there's a ton of stuff that's available in Python Neo's API, but that is the gist of it. You can, of course, set properties on relationships. Maybe I should show that. The syntax is same there, where you would say, where you pass the three necessary arguments, which is from node and relationship type and to node, and then you could add a key value pair there on the end, and you can add as many as you want there. You can append as many as you want to that, and that would create another relationship with a property of weight on it. So that is, in a nutshell, the Python Neo API. But let's jump into, let me actually delete all this data real quick so I can show my other script. So this should be a clear database now. Okay. So let's look at a more realistic example of using Python Neo for data collection. As Adam said, we were going to look at how to collect tweets via the Twitter API. I'm going to share this this script on as a graph, or not a graph gist, but a GitHub gist, and so you can all use it for your own purposes. But basically, I'm importing the same things that I did last time in my little example just now, graph node and relationship from Python Neo. And then I'm going to use the requests, the Python requests library, which is a really, really great HTTP request Python package for talking to APIs, or that's how I use it specifically, and then a few other helpers here. So don't get too involved with this. This is just talking to the Twitter API and getting a bunch of tweets back as a Python dictionary. And you can go through that on your own time. Essentially, we're using Python's search API to search for a keyword that we're going to pass to this script as an argument. So definitely go through these details on your own time. But that's just talking to Twitter API and getting a dictionary back. What we're really going to look at is this upload tweets function, as it's a more realistic example, like I said, of using Python Neo for data collection. And in this specific example, we're going to collect data on Twitter. And so I'll go ahead and walk through this step by step, but of course I will upload it and you can learn about it on your at your own pace. So we're going to start that graph object again, like we did in the little example. And then we are getting a list of dictionaries back from the Twitter API. So we're just going to iterate through each of these dictionaries and create the graph. And we still have not used any Cypher, which if you are familiar with Cypher, that's great. But if you're not, I just wanted to show that you can use Python Neo to create a Neo4j graph database without learning our query language first. Even though it's very easy to learn, and I'll show some of it later, you don't need it to get up and running with Neo4j immediately. So we can actually just use the very convenient Python Neo API calls here. So first we're going to extract out the user dictionary. It's like a dictionary within a dictionary here. The user entity out of that, out of each tweet, and then the entities is going to contain stuff like hashtags and links and mentions. which is going to be another, both U and E are going to be dictionaries here. So first we're going to create the tweet. We're going to use the merge1 function here, or the method rather, on this graph object, which is going to use merge, which what it does is it will find or create a tweet. So this is the first argument here is a node label. So we want a tweet node that has an ID property of this value. And this is going to give you the ID of the tweet. Every tweet has a unique ID, and I'm getting that out of that dictionary for every teen tweets, right? So that is going to get me the tweet object using merge1. I'm using that because some tweets, for some reason in the Twitter search API, they will show up more than once. And I don't want to create two tweets if it's the same ID. I just want to find it or create it. So that will do that, and then we're going to set the text property equal to the text that is sent as the text key of this dictionary, and push it to create that tweet. And then we will also use merge1 to find or create the user. Of course, users are going to show up multiple times in our search, assuming that they're tweeting about something multiple times. So here we're going to find or create the user using merge1. Again, the first argument is the node label, the second is the property key, and the third is the property value. So this is going to find a user node with property username that is equal to the screen name value out of this user dictionary up here. And then we'll find or create that user, and then we're going to create the relationship that the user posts this tweet. So we're just using that same relationship function that I showed earlier, where we're going to take a from node, a relationship type, and then a to node, and we're going to say a relationship user post tweet, right? And then here we're going to iterate through. So here we're going through the entities dictionary, which has a key hashtags, which is going to give us a list of hashtags that tag that tweet. So here we're going to use the same thing. We're going to merge. We don't want to create the hashtag nodes more than once. We just want to find or create it. So same thing here. We're going to find a hashtag node with a name property that's equal to the lowercase version of the hashtag. And for each of these, we're going to create the relationship that the hashtag tags the tweet. Okay, and then we are also going to capture mentions. So same story here, merge1, we're going to find the users that the tweet mentions. So that's going to it's going to find that user by username and with the value of the screen name that's returned from the Twitter API. And we're going to create the relationship that the tweet mentions these other users. And finally, or not finally, we, second to last here, get the tweet that it potentially is going to reply to. So some tweets are direct replies to other tweets. So here we're saying we're getting that key out of the dictionary, and if it exists, we are going to find that tweet or create it by its ID, and then we're going to create the relationship that if the tweet was in reply to this other tweet. And now finally, we if the tweet is a retweet of another tweet, we also get that returned with the Twitter API as retweeted status. And then we can extract that ID out, and again, if it exists, we will find or create that tweet by its ID property, and then we'll create the relationship that the tweet in question retweets this other tweet. So that is our schema in a nutshell, and this will be more clear perhaps when I run the script and we get some data in there, and I'll click around and show you guys what it looks like. We're also going to add some uniqueness constraints using Python-Neo's create uniqueness constraint method here. We're going to make tweets unique by ID. Users must be unique by username, and hashtags must be unique by name. And you can investigate this function on your own time, but that will either create or, if it already exists, it will not these uniqueness constraints, which also creates an index on the node label property pair. And we're going to set a since ID. I'm only going to run this for a few seconds, so it doesn't really matter. But essentially, we're going to find tweets by a keyword that I specify in the command line. Update the since ID so we don't find the same tweets every time. We're going to send that list of dictionaries to upload tweets, which I just ran through. And then the Twitter API is rate limited, so we're going to sleep. Again, you can go through that stuff on your own time. So I have this sitting in here. Let me make sure that I have my Twitter bearer set up. I'll also include instructions on getting your Twitter bearer if you do actually want to. You should make this a shell script. If you do want to collect your own Twitter data. So as I showed you earlier, my database is empty, so if all goes according to plan, we're going to let's see. We're going to collect tweets with keyword Python. This argument right here is being passed as the keyword that we're sending to the Twitter search API. So if all is well, this will run until I stop it. But let's see if we get any data. And we do. Excellent. So I'll just go ahead and stop that, even though you could technically run it forever and sit there and collect tweets until you run out. So this is the model that I of the tweet. So we can see that this one had hashtag JavaScript, HTML5, Java, C#, Python. And so all of those things were parsed out, and we can see that all of them are these hashtag nodes with tags relationships to the tweet. We also see that this is the user that posted the tweet, and it also mentions these two users, this guy and that guy. So that is the model in a nutshell, and that is how easy it is to collect data from any API really and add it to Neo4j. So now let's go into, actually let me jump back into the PowerPoint here, Neo4j and IPython, which work very nicely together actually. And for completeness, these are all the packages that I installed prior to making this IPython notebook, but don't worry, when I send out this notebook in the post-webinar email, you'll get an IPython notebook that has a few more notes on all the packages I installed. But in a nutshell, of course, you need the IPython notebook, and then we're going to use IPython Cipher, which gives you the Cipher magic, which I'll show in a second, and then ggplot for making some quick charts. And then NetworkX, which is a graph analytics engine, a Python library that will allow you to do lots of fancy graph algorithms on subgraphs of your Neo4j graph, which again I'll show. And then some dude's word cloud package from GitHub, because no webinar is complete without a word cloud. So let's get back into the notebook. Okay, so it's very, very easy to use, like I've been saying, Neo4j in IPython notebook. So this is, I think this was made with it was made with the same data set that I imported just now, but it's I had run it earlier for longer, so I had more data. So it will be a bit outdated, but that is okay. So first, you will load the Cipher magic extension here. With this is only possible after you've installed IPython Cipher, and then of course I'm going to say I want my plots to be in line. So there's a few ways to use this cipher magic. First is to use this double percent cipher magic here, where you will just write a cipher. How long has it been out?
All right. Sorry about that, everyone. Let's try. Nicole, do you want to mute yourself? You can talk off of mine.
Yeah. Where do I do that?
Yours is back. You should be good.
Oh, it's good? Yeah. Okay, so do you know when it cut out? Where should I start back?
Why don't you start back with starting with the cipher explanation, with what the syntax means.
Okay, yeah. So, right, this is our first view of cipher. Everything after the match clause should be pretty familiar. So in SQL, the first, the select statement, in the select statement, you define all the columns you want to return, but in cipher, that is at the end in the return clause, so that is different. But then in the match clause, you're actually matching on a graph pattern. So here we're matching on user nodes. We're defining that it has to be a node label of type of user, here with the colon, with an outgoing relationship type of posts to a tweet node. So this is only capturing user posting tweets. It's not capturing any other of these types of relationships that are that exist in our graph. It's only matching on user posts tweet. And then we're going to return the screen name of, this is using an old, sorry about that, an old database where I called it, I called the property screen name instead of username. I'll update that after this. But essentially, you return properties in a table like this from Neo4j by using identifier.property name. Identifier.property name. This is the same where the text property on the tweet will give us the text. And I'm just returning 5 randomly. So here we have people's screen names and then the text of the tweet. Right? So, and that is made possible with this cipher magic right here, where you have double percent cipher and then the cipher query, and then it will display within line. Okay, so this next cipher query about the same. We're matching on a different pattern here, but here we're matching on a tweet type node, a tweet node label with outgoing mentions relationship to a user node. And here we're returning the screen name of the user and the count of how many tweets have mentioned that user. So this is going to count how many of these patterns exist, and it's going to group by the user screen name. You don't have to tell it to group by, you don't have to use the word group by. When you use an aggregate like this, it's going to do it for you. So here we're getting the top mentioned users because we're ordering by this count descending and limiting 5. So we're getting the 5 top mentioned users here. Pretty easy. And here we are getting the top hashtags by how many times they have tagged a tweet. So here we're matching on hashtag nodes with outgoing tags relationships to a tweet node, returning the name of the hashtag and the count of how many tweets that they have tagged, order descending, limit 5, so this is the top 5 hashtags. So that is cipher. That's some pretty basic cipher, tabular cipher to display some basic information about our graph. Let's also look at some plotting though. I decided to use ggplot because I do not know how to use matplotlib, and I'm an R person, and ggplot is very natural to me. And I want to show that in just a few lines we can make a pretty awesome heat map like this. But let's go through what's happening here. Notice I'm going to be using the cipher magic a little differently. We can actually assign cipher query results to a variable. So here I'm using just 1% on the cipher magic, and then here's my cipher query that's getting hashtag co-occurrence in a kind of fancy way. I'm matching on hashtags tagging tweets. So this is similar to getting the top 5 hashtags up here, but I'm getting the top 10 hashtags by just count, and then I'm going to collect them into a collection. And if this doesn't make sense, don't worry. This is kind of advanced cipher, but if you go online, you will find some cipher courses that will make this seem very simple. We're going to collect those hashtags into a collection, these top 10 hashtags, and then we're going to unwind both of them. We're going to unwind them twice, so we get both an H1 and an H2. And then we're going to match on their co-occurrences. So once we've found the top 10 hashtags, I just want to keep those, and then find how many times they co-occur. So this is what this pattern is describing. We're matching on tweets that are tagged by these two hashtags, and this will return the hashtag 1 name, the hashtag 2 name, and then the count of how many times that they've occurred together. And so you can kind of think of this as an edge list almost, where we have Python and Flask were mentioned 7 times together, right? And so that's just showing this top 5 rows. But so here we assigned this cipher query results to results, and then IPython cipher has a very convenient .getDataFrame method that will turn your results into a pandas data frame. So that's what DF is. It's a pandas data frame, and I'm showing the top 5 rows here. And then in ggplot is extremely simple. Once you have your data in a data frame in the format that you want, to create some charts. So here I'm passing, of course, the data frame first. If you're an R person, or if you've ever used ggplot, this should look very familiar. And then we will pass the X value, the Y value, and then I want this to be a tile that's going to fill by the count. So this column over here, and so the color here is a function of this count. So the darker the color, the more times that they've been mentioned together. So we see that Python and Java were mentioned heavily together. And I thought it was interesting that Flask, most of these hashtags, you see this is mostly full grid here, where most hashtags are mentioned with other hashtags like HTML5 is also mentioned with coding in C# and Geek and Java. But Flask is only mentioned with Python mostly, and I think once with JavaScript. So Flask seems to be, only mentioned with Python, which is interesting because I feel like it's also related to HTML5 and JavaScript. But so that was an interesting find. So I just wanted to show how easy it is to get your cipher query results into a pandas data frame, and then in one line with ggplot, we were able to create a pretty fun and compelling heat map here of hashtag co-occurrence. And like I said, we would not be complete today without a word cloud. So I've installed some guy's word cloud package. And here I'm just going to get, this is a pretty simple cipher query. I'm matching on all tweet nodes that have the text property and returning the text, right? And then that's going to give me a cipher result list. And then I'm going to start with an empty string and append all that text to it. I'm going to get rid of some stuff that occurs in most tweets, so it's not dominating my word cloud. I'm going to start a string IO and read it in, and then essentially this is it. Word cloud is words generate text, where text has to be a file input. And we're going to plot it. So this is my really awesome and super interesting word cloud of tweets that have the keyword Python in them. And finally, last but not least, I think the most useful part of this IPython cipher plugin for IPython Notebook is its ability to coerce cipher query results into a network X graph. So here first we're going to import network X, and then we're going to do the same thing where we use the cipher magic to return a cipher query result and put it on our variable results. But notice here that I'm returning actual entities and not properties. Previously, up here, we had, I was returning an actual table. So this query will return tabular results. Maybe I should show this. Tabular versus graph results. So if you do something like match user posts tweet, return u.name t. Yes, it's username, name t.text. That's going to give us a table. Oh, great, emojis display perfectly in the browser, which is good to know. This is going to give us a table, right? Because we've returned the properties off of those entities. If we just return the entities themselves, U and T, we're going to get a picture in the Neo4j browser, and this is a graph result, right? So that is an important distinction to understand. So when we write this cipher query, I'm actually assigning the entire pattern to an identifier P. So this is going to be a path. You can assign entire paths to identifiers like this. So I'm matching on the pattern where two hashtags tag the same tweet, which is something we did a bit earlier, and assigning it all to P, and then I'm returning 10 of those patterns randomly. But this is just to show how easy it is to coerce cipher query results into a networkx object. So here we're going to use IPython's getGraph method. So again, we're assigning those results to results. We're going to use getGraph, which will give us a networkx graph object. That's what G is. And then we can just use nx.draw, networkx draw, and that will display your graph in line. So just in a few lines, you're able to get cipher query results into a networkx object and plot it. And of course, this opens a lot of doors. NetworkX is not just a plotting library. You can also do all the graph algorithms that are available in NetworkX, such as between centrality algorithms, community detection, and stuff like that. I also wanted to show a few more examples of course, you know, Neo4j has different node labels, different relationship types, so you probably don't want all your nodes to be the same color like here, because this pattern actually returned two different node labels. It returned hashtags and tweets, but they were all colored red. Perhaps you want to actually color your tweets differently. So here I'm going to define a node label color dictionary here. And then in xdraw, you can pass this node color argument that's just, you can figure this out on your own time. Essentially, the hashtags are pink and the tweets are purple. So that's a more realistic plotting example. And just another example, you might want to size your nodes by some function. So here I'm sizing the nodes by their degree. That's just another node size argument to an xdraw. So this is the same thing, just sized by the degree of the nodes. Right, and then another example, this is a different pattern. I'm matching on, I'm getting both different node labels and I'm getting different relationship types. I'm getting posts and retweets here. So same thing here where I'm just adding an edge map where I'm saying I want the retweets relationships to be this color and I want the post relationships to be this color. And this is the result of that. So just a few examples of how easy it is to integrate Neo4j into IPython, into pandas data frames, and to networkx graph objects. So that is all I have for using, oops, I should have showed you guys that, for using Neo4j and Python together. This is the link to that IPython notebook I just showed, but it's also going to be included in the webinar. So that is all I have for today.
Great. Well, thank you, Nicole, so much.